This video is a continuation of the question and answer video posted in November. This one will be more focused on particular glitches or aspects of games. Let's jump into it. In Super Mario Bros., there's a glitch that occurs when you take damage and touch the axe at the end of a castle level at the same time that messes with Mario's status. Why does Mario get glitched out by this? One byte controls his power-up state. It starts in state 0, goes up when a power-up is collected, and is reset to 0 when taking damage. Only in state 2 will Mario be able to shoot fireballs. The second byte controls his size, 1 for when he is small, 0 for when he's big. Normally, these values are synced up all the time. Power-up state 2 only occurs when Mario is big, for example. However, when hitting the axe and taking damage at the same time, Mario's power-up state is reset to 0, but his size isn't changed. So he'll be in state 0 when still big. Now that the values are desynced, they stay desynced until Mario dies. After collecting a mushroom in this state, Mario will be in state 1, but at a small size. And then a fire flower will put him into state 2 while small. This results in small Mario that is able to shoot fireballs. How do fire flowers display 4 colors and transparency? If you look at the fire flower sprite as a whole, you can see the 4 unique colors along with the transparency around it. But the fire flower is actually made up of 2 distinct tiles, both of which are duplicated and flipped horizontally to make the whole thing. The top half uses a different palette from the bottom half. Its palette even changes every 2 frames to make it look like it's glowing. Explain the SMB 4.2 warp bug. When it comes to sub-level transitions in this game, instead of transitions being assigned to pipes or vines, they are assigned to a separate room change object that is placed somewhere nearby. Only one transition can be active at a time, and when one of these objects is loaded, the current transition is overwritten with the new one. The location of the room change objects are chosen in such a way that they are loaded right when Mario arrives at the pipe or vine, so it can take him to the correct sublevel. However, due to 2 things, it is possible for certain pipes and vines to take Mario to an unintended location. The first is that some of these room change objects were not placed in an optimal location, so the active transition is switched too early or too late. The second thing is that Mario can be forced towards the right side of the screen using certain tricks, which is an issue since the room change objects are loaded relative to the screen's position instead of Mario's position. The wrong warp in 4.2 that abuses this behavior is the most popular version of this trick since it is used in the speedrun of the game. In this level, there is a vine and a pipe that are less than 2 screens apart from one another, which is almost too close for 2 sub-level transitioning objects when using this method of keeping track of where Mario goes. The room change object that corresponds to the pipe is located up here, and the one for the vine is way back here. So once the camera reaches this location, Mario will go to the bonus warp zone area if he leaves the level by any means, and once it reaches here, he will go to the underground sublevel. The goal of the wrong warp is to enter the pipe before the camera reaches this position, which is possible if Mario is on the right side of the screen. Normally, Mario stays in the middle of the screen when advancing in the level, but by exploiting some mechanics in the game regarding the camera, Mario can be pushed towards the right. The easiest way of doing this is just sticking Mario in a wall by using the ceiling, which will cause the game to try to eject him out by pushing him all the way to the right. The faster way is to jump backwards into walls and blocks, which will slowly nudge Mario a bit to the right each time, and just enough to get into the pipe. This trick is also done in 8.4 in the speedrun, but it utilizes the reverse outcome. By running past this pipe, the room change object is loaded for the next pipe, but it is faster just to backtrack and enter this pipe instead. Jumping over the flagpole in SMB1 is entirely possible. With enough time, could a player run to the right long enough for the level to loop back to the start? Actually, the level doesn't loop, as it turns out. At X position hex 8000, about halfway around, some glitchy graphics appear in the sky, but then those disappear when Mario's position overflows back to 0. This happens because the routine that pieces together the background treats the high byte of the screen coordinate as a signed byte and never expects it to be negative. Then, when trying to load the tiles from an internal table, it is indexed out of bounds and garbage tiles are read instead. While the background scenery fixes itself when Mario's position wraps around, the actual parts of the level never load again, so there's nothing to do out here other than to run to the right forever. How does the Super Mario Bros. Double jump work? There is a single byte that marks if Mario is in the air. This gets cleared during a power-up transition. So from the game's point of view, Mario is standing on the ground anytime he is collecting a mushroom or fire flower. To trigger the double jump though, you had to have released the jump button before touching the power-up, or else it will be treated as one big jump instead of two separate ones. What causes SMB's HUD to jump to the right when too many objects are on the screen? Super Mario Bros. 1 used the most basic ROM structure, namely, it did not use a ROM mapper. Without a ROM mapper, the programmers could not make use of programmable interrupts. Interrupts are very useful when some code needs to run at an exact particular time during the frame of execution. In Super Mario Bros., the background horizontal scroll register needs to be updated mid-frame. Since the HUD and the main level geometry were both on the background, updating the scroll value while the frame is rendering allows the HUD to remain in place and the level to smoothly scroll while playing. Without interrupts, however, the programmers had to fall back to a very limited native functionality of the NES called Sprite Zero Hit. The NES could produce an image with 64 sprites, or objects, on screen at once. The first object in memory, Sprite 0, is special in that a certain flag is set in a PPU register when it is first visible on the screen. Programmers could use the position of this sprite, along with periodically checking this flag, to determine where the scanning beam was located during execution. You probably didn't know that this little coin icon in the HUD has a hidden sprite behind it, which is actually visible when this glitch occurs. This is Sprite 0, and when the Sprite 0 hit occurs, the programmer knows that the HUD is almost done being drawn and to update the scroll register soon. However, just due to the structure of the code, when the game is lagging, this PPU flag is not checked during the extra lag frame, so the scroll register is left as it is for the next frame. These two outcomes alternate back and forth when the game is lagging a lot, which is why the HUD flickers a lot when this happens usually. Why does the original Super Mario look so basic, but Super Mario Bros. 3 looked much better? Like I mentioned before, SMB1 had no ROM mapper, so it was limited to the smallest amount of character data, or 8 kilobytes. SMB3 had the MMC3 mapper, and it had 128 kilobytes worth of graphics. Not only does this mean it had more variety in terms of level aesthetics, but this also allowed it to swap out character data banks to animate tiles, something SMB1 couldn't do. Combine this with the fact that SMB3 came out 3 years after SMB1, the developers had that much more time and experience to make a better looking game. In SMB3, can music be played instead of other music but have the same sounds? Like if the music box song played instead of the World 1 theme but had all of the World 1 sounds? Sure, the game has 7 different instruments that the square channels can use. Here's what the music box sounds like with the World 1 song instruments. I doubt there's a simple way to achieve this effect in real time using a glitch without using arbitrary code execution. I kind of wonder what would happen if SMB3 used vertical mirroring instead of horizontal mirroring. Would the top of the screen glitch instead? I plan on making a video on this, but for now I'll show you why vertical mirroring couldn't be used. You can see that the status bar just gets in the way since it gets mirrored too. I'll have more details about this in the video. What exactly is being traded when you trade Pokemon? A lot of people replied to this comment already, but I'll answer it too. Since the two games trading Pokemon are nearly identical, they don't need to exchange any data that already exists within the ROM, so like the Pokemon's graphics, dex info, etc. What does need to be sent over the connection is things that are specific to that one Pokemon only. like which Pokemon it is, an ID number, not the species name, its nickname, stats, moveset, etc. The players' names and all of their party Pokemon are exchanged at the start of the trade, so you can browse through them in the menu. Then for the actual trade, a couple of commands are sent to identify which Pokemon each player has selected to trade, and then another couple to confirm the trade. The Pokemon then get swapped into the party on either end. I hate to ruin the magic, but no communication between the games occurs during this entire cutscene, only afterwards to confirm that the trade is finished and prepare for another trade. There's a glitch in Pokemon Red and Blue where, when you throw a Pokeball at a Pokemon, there is a weird audio effect that gets applied to the music up until the first shake of the ball. I've always wondered what the purpose of the effect serves in the sound effect, what the throw would sound like without it, and what the music would sound like if it was applied to more of it. The Pokeball throwing sound effect has a sound command that is responsible for the pitch bend of the note being played. However, this command is applied to all notes that begin after the command until another command is issued to cancel it out. This sound effect does not have another command at the end to turn off the pitch bending. The sound effect the Pokeball makes when it lands does have a command to cancel out the pitch bending. This means that all of the notes of the background music that play on the first pulse channel between these two sounds being played will have that same pitch bend effect as the ball thrown sound. Here's an example of this sound glitch occurring. And here's what the throwing sound would sound like without that pitch bend, and if the pitch bend were never canceled out. How are Super Mario World's sound effects programmed? Like, how are the samples put together in sound effects? Generally, sound effects are treated as short, small songs that are injected into the currently playing song by overriding certain channels. They can use samples made specifically for that sound effect, or any sample used by music as well. For example, take the orchestral hit sample used in the bonus room music. Isolate it, pitch bend it up a bit, pitch bend it down a bit, then play those two notes back to back. During the demo sequence in Super Mario World, if a key exit is triggered, a playable version of the demo is presented. This shortened version of Groovy is half as long, contains no gold tape, and you will have 2 lives with no time limit. If a normal exit or key exit is triggered during this playable sequence, the level will restart itself. If you run out of lives after dying twice, the level will start with P5 lives, and as you continue to die, P5 lives will decrease until you reach C9 lives. Then the level will restart once again, this time with 99 lives. Super Mario World uses a hex to decimal conversion routine that only converts 1 digit's place at a time. For a number that supposedly caps at 99, the routine is only run once, to separate the 1s from the 10s. For a number like 100, which is 64 in hex, the 1's place is found to be 0, and the 10's place is 10, but it is still in hex, stored as hex OA. So you get A0 for 100. 255, or FF in hex, is found to be 5 1s and 25 10s, still in hex as 19. The graphics for the numbers and letters are stored in order starting at 0, going up to 9, then A through Z. So hex F gives you tile F, and hex 10 gives you tile G. Hex 19 is P, which is where that comes from. The number of lives jumps from C9 to 99 because C9 lives corresponds to the internal hex value of 80, since 1 is added to get the number of lives shown on screen. This byte is treated as a signed byte, so the highest bit is set when it is a negative number. The moment this value overflows back to being positive, it is again capped off at 62 hexadecimal, which is incremented to hex 63 and converted to 99 in decimal. If you spawn the invisible Koopa boss, the level will also restart, but with a modified version of Yoshi with no ducking or running animations. If you despawn Yoshi and get it from the question block again, the game will replace Yoshi with the wrong sprite, and when mounted, you will die. The glitchy Yoshi graphic has to do with 2 things. First, if a certain cutscene flag is set, Yoshi's animations will be skipped. This had to do with overwriting his animation for the credits. By beating the level via the Koopaling sprite, this cutscene flag is set, since you are about to beat a castle, but it isn't clear upon re-entry to the title screen level because the cutscene never actually played. And second, because the flag is set, Yoshi's animation is never initialized after growing up from an egg. I made a write-up on this glitch about 3 years ago that explains exactly why this happens, which is a bit too long for this video. The reason I did so is because this glitch could theoretically happen outside of the title screen due to the fact that this flag is also not reset upon completion of the sunken ghost ship, but only if that level is cleared via the Big Boo boss, which is currently impossible to spawn in that level. I've always been boggled by how arbitrary code execution or power-up incrementation worked in Super Mario World, and I was wondering if you could explain how one of them works. Lucky for you, I made 2 videos a long time ago on my other channel that explains both of these. The credits warp video is a little outdated, but it still explains how the arbitrary code execution is possible. I was watching the SMW TAS of all 96 exits on TAS Video's channel, and near 19 minutes and 20 seconds in, Yoshi turns into a glitchy mess. Why does this happen? To answer this, we have to rewind all the way back to the start of the previous level. Notice how when Yoshi flies off the bottom of the screen, that this checkerboard platform appears at Mario out of nowhere? The platform is actually the platform that should have spawned on this third line guide. It warped to Mario's position and had its properties modified because it was loaded in on the same frame that Yoshi despawned off the bottom of the screen. When this happens, Yoshi and the sprite that spawned have their properties fused together. Namely, the game still thinks Yoshi exists in the level, which is why he exists on the overworld after this level is over. Yoshi's palette and graphics page are copied from the sprite that was swapped. Normally, Yoshi uses palettes 2 through 5 and uses graphics page 0, but the brown platform uses palette 0 and graphics page 1, so this is what the new Yoshi will use as well. What's your favorite SMW jank? There's one routine in the game that is called when doing a switch jump. So there's a list of pointers to routines, and the one that gets jumped to is determined by the value in the accumulator, starting from 0. This routine is used quite a bit, and every time it is called with a JSL instruction. Except for one single instance where the sequence is PHK, PER3, JML. This does the exact same thing but with 3 instructions instead of 1. And this is also the only use of the PER instruction in the entire game. How long would it take to break every block in Star World 1 in SMW? Okay, so this isn't trivial. You need to have a cape because there are places where you need to go back up to actually reach all of the blocks. Having the cape also makes the blocks spin, and then you can't break them right away, which is annoying. Then you have these blocks that are right under a ceiling. You can break the ones on the side by clipping into them from the side, but to get the ones really far under, you actually have to duplicate them upward to overwrite the floor and then break those. It's way more work than you'd initially think. That being said, I raced one of my friends one day to see who could break them all first. It ended up being around 40 minutes, but it could probably be much faster if you get every duplication and clip first try. In Battletoads for NES, how does the screen work in the race levels in the game, such as levels 3 and 7, specifically in the latest where there are many sprites of missiles, lightnings, and stuff flying by through the screen? The background in these areas is the main spectacle. Even though Battletoads uses a ROM mapper, this mapper does not include IRQ functionality, so it must rely on sprite 0 hits to time stuff. The background scroll register is modified manually to create the parallax effect on the top parts of the background. This had to be done manually by counting cycles, since this isn't the SNES with its HDMA capabilities. Then, just like Super Mario Bros., there is a hidden sprite you can't even see that acts as the cue to process the parallax of the bottom part. The background fades from rocks to fire by slowly replacing pixels from one tile set to another across a handful of frames. This is possible since Battletoads maps character data to a portion of RAM within the cartridge instead of ROM. This allows the graphics to be modified down to the pixel on the fly. Once we get airborne, the pink fire up here is skewed back and forth by modifying the background's horizontal position each scan line, which is also done manually, again by counting cycles. Everything else that is moving in the foreground is an object, which includes the lightning, missiles, and the toads. What is up with the boot screen for Pac-Man? Is that the memory being loaded? This is the memory check that happens every time you boot up the machine. It makes sure that every bit of work RAM, video RAM, and color RAM are working properly. If something is wrong, it will just continuously reset the machine. If you put the machine into service mode, it will report the result of the test instead of starting the game. How does the X-ray scope in Super Metroid work exactly? The slice is just a window effect using HDMA, very similar to the example that was shown in the SNES features video about HDMA. As for revealing the fake tiles, the clue that should tip you off is the fact that the background disappears whenever the scope is active. This means that the background layer is temporarily being used for another purpose, so the backdrop needs to be removed for the time being. In this case, the foreground layer is duplicated to this now empty layer, but with all of the fake tiles removed or replaced. Then, the same window that produces the wedge shape is used to mask away the main foreground layer, leaving behind the true identity of the tiles to show through underneath. Why do the PSI in Earthbound look so relatively low quality compared to their beautiful backgrounds, models, and text boxes? Is this just a stylistic choice, or are there hardware limitations? The battles in Earthbound use background modes 0 or 1 depending on which kind of background is being displayed. In Mode 1, Layer 1, a 16 color layer, is used for the PSI effects. Layer 2, also 16 colors, is used for the background, and Layer 3, just 4 colors, is used for the text boxes. In Mode 0, though, all background layers are limited to 4 colors. Layer 1 for the text boxes, Layer 2 for the PSI effects, and Layers 3 and 4 for the two backgrounds. In one case, the effects are 4 colors, and in the other, they are 16 colors. In order to make them consistent regardless of the type of background, they were limited to 4 colors in all cases. This explains why they lacked variety in color. They also took up a good size of the screen, which limits how quickly the tiles could update and how many unique tiles could be reserved for effects. This isn't to say that the attack effects couldn't look better than they already do, but I can't answer this question fully without asking one of the game developers themselves. During the final boss of Yoshi's Island, normally you're supposed to die when Baby Bowser gets close enough to the screen, but if you survive through some sort of glitch or cheat, Baby Bowser will eventually start walking backwards while being upside down. After he gets small enough, you can see that the sprite tiles in a way where there are multiple copies of the sprite in a grid-like shape, all walking away and growing smaller. It's such a strange error, and I'd really like to know how or why it works the way it does. You are witnessing the edge cases of Mode 7 transformations. Baby Bowser takes up a small portion of the center of the Mode 7 tile map. At 100% scaling, he looks about this big. As he gets closer to the screen, the Mode 7 matrix parameters tend towards 0 in order to increase his size. When the parameters hit 0, the entire screen fits into a single pixel of the background tile map, and Baby Bowser becomes infinitely sized due to a division by 0. Then, when the value goes negative, the tile map flips in both the X and Y direction, which causes him to be upside down. Then, the value goes so far negative that its magnitude becomes larger than the intended range, and you start to see the entire Mode 7 background tile map on screen at once. As it gets even smaller, you'll start to see copies of it since the tile map is set to repeat to fill the screen. This normally wouldn't even be possible, which is why this issue wasn't addressed. If you left this going, eventually the matrix parameters would overflow back to the positives, the background would flip again, and everything would get larger again until it falls back into the intended range once again. Teenage Mutant Ninja Turtles 2, Back from the Sewers for Game Boy, has a surprising amount of quality digitized sound. Is the playback method different from the one used in Pokemon Yellow? This game does use the same method of using 1-bit samples and modulating the volume to make these sound effects work. The algorithm it uses is slightly different, but it gets the same job done. Thank you for watching, and special thanks to all of those who left comments for this Q&A session. I definitely wasn't able to answer every single one, obviously, but I got a bunch of new video ideas from some of the questions you asked, so look forward to those in the future.